Good day. Welcome to our session. On this session, I'll be covering functions where I'm going to focus on the parabola graph. If you are new to the channel, please subscribe and then like and share, and also go through our playlist and check other previous topics that we've covered. So the parabola graph will be done from grade 10 until grade 12. So this content will help different grades, but I'm going to focus mostly on grade 11 and grade 12 content. Also grade 10 will learn something from the content I'll be covering. So without wasting any time, I'm going to go straight to the lesson. So first thing first, we need to know that we've got two different shapes of parabola. For example, if I were to draw a graph, let's say I draw a straight line graph, and then I just come there and put a shape like that. So that shape is the same shape as this one. So normally we call an open shape like this a happy or a smiley parabola. Some call it a smiley parabola, or you can call it a happy parabola because the shape there resembles a smiley or a happy mouth. So that's like a smiley parabola. Then the one that looks like this is like a sad face. Normally people with a sad face are going to show that type of expression. So we call this one a sad face. So and then also, since we're dealing with functions, you need to know how each function looks like. For example, with a parabola, the function will always can either be fx or jx or whatever letter, but you'll get a typical expression like this, which will be a x squared plus bx, ax squared plus bx plus c. So it's ax plus bx plus c. So this type of expression looks similar to a quadratic sequence. Remember from number patterns. So it's ax plus, this is b plus bx plus c. That's the typical expression of a parabola. So you know that we've got a, b, and c. So the first thing that you must ask yourself, why am I having a smiley or a sad face? If the value of a is less than 0, or if the value of a is negative, you get what we call a sad face. So to avoid confusion, let me just put this expression next to the sad face. Yeah, so that to avoid confusion. So if your value of a, let me just put in the sad face here. If the value of a is less than 0, or it's negative, if a is negative, the value of a here is negative or less than 0, you get a sad face. But if a is greater than 0, or if a value is positive, then you get a smiley face. So whatever they give you as an expression of a will tell you the shape that the graph must look like. So that's the first thing that you must know about parabola, the shape. So now the other thing that you must know about the parabola, if you look at the parabola here, the graph, for example, it can be decreasing, and then out of nowhere it turns up and goes up again. So every parabola, there's what we call a turning point. So parabolas have what we call a turning point. So if they give us an expression like this, which is having a, b, c, and then they ask us to find the coordinates of a turning point, we normally use this formula to find the turning point coordinates. So to find the turning point coordinates of this type of parabola, to find the x value, the formula would be x is equals to negative and then b over 2a. That's how you find the x value of the turning point of this form of parabola. Remember, this will apply if I'm given a, b, and c, and then I want the turning point coordinates. And then to get the corresponding y value, you just need to go and put the x value that you got where there's x on your equation. So I think let's do an example to show how this will look like. Let's say they give us a parabola, and then they're saying that let's just make a negative. Let's say we've got negative 2x squared. So our a is negative 2. So we know that we're going to get a sad face. And then plus, let's just have b as 4x. and then let's just have C as C could just be 5, for example. Just have C as 5. So that would be a typical parabola of this format. So if they ask us to find the turning point of this parabola, we know that the first thing is to use the formula. So it will be x is equals to negative and then b over 2a. So now you need to go and put the values. Remember, the first value you have here is a, second value is b, then third value will be c. So from here onwards, we know we're going to have negative. And then what is the value of b? It's 4. Ne? So always put b in bracket in case if b is negative. Ne? So always put b in bracket because sometimes you can get a negative b. Then over 2, again put a also in bracket, ne? Which is negative 2 this time around. So this thing, we can simplify this. This will be negative 4 over negative 4. That will give me 1. So my x value of my turning point is 1. Remember, turning point must be a coordinate, meaning I must go and find the corresponding y value. So this will be y is equals to, wherever you see x, we're going to put 1. So it will be negative 2, and open bracket. Where you see x, you put 1. I'm going to put 1 there, and then squared, and then plus. Then we see 4, and we're going to see 4 here, and then again, where we see x, we're going to put 1 there. So it will be x, and then put 1, and then plus 5 there. So we just need to put that whole value in the calculator, and that will give us an answer straight there. So this will be negative 2 plus 4, that will be 2 plus 5, that will be 7. So if my mental calculation is correct, the y value that you're going to get here will be 7. Ne? So meaning the coordinate will be, remember x is 1, so the coordinate of the turning point will be 1, and then the y value is 7. So that will be the turning point coordinates of that parabola. So for practice, let's also do another example just for practice sake, so that at least you guys can get used to working with this type of parabola. So remember, turning point, and then the shape, we know it will be sand because a is negative. Ne? So now let's do another example just to show you guys how, let's say for different values, how different values will look like. Ne? Let's say now they give us a different parabola. Say that it's y, then it's equals to, let's say now we've got a positive a value. Ne? So a now will be positive. So it'll be 4x squared. So this one will be 4x squared. Yeah, I know, guys, that's a terrible x. So sorry for my handwriting, that's a terrible x. Can't have that terrible x there. So let's say we've got that, and then that will be x squared. And then let's say now let's just change b to become negative. So this would be negative 8x now. So my b is negative now, and then plus 3 as our, or plus 3. It's fine. That's your parabola that we're having now. Remember, with the parabola, we've got a, b, and c. So again, if they want us to find the turning point coordinates of this parabola, we know that the first thing is to the formula, which will be x is equals to, x will be equals to negative b over 2a. So it will be negative b over 2a, and then we know from there onwards that you need to look at each value that we're given. And again, from my advice in the previous example, whenever you put the value of b, always put b in bracket. So negative is from the formula, and then our b is negative 8. So just going to open the bracket, put your b in the bracket, which is negative 8, and then over 2, then open another bracket for a. Our a is 4 this time around. So that would be a, which is 4, and then from now on, we know that negative and negative is positive, so the answer will be 8 over 8. Again, we'll get 1. So just know that in exam we'll get a different value, but here I'm getting the x as 1. So you guys must not assume that every example will always give us x of 1. So now remember, once you get the x value, we need to get the corresponding y value. So the corresponding y value, just go where you see x, we're going to put 1. So we're going to put 1 where there's x. So this will be 1 squared. So the way you see x, we're going to put 1 and then minus 8. And then where we see x, we're going to put 1. So wherever you see x, we're going to put 1 and then plus 3. And then plus 3. So that will be your parabola. Sorry, your corresponding y value. So this will be 4. 4 minus 8 will be negative 4. Negative 4 plus 3 will be negative 1. So your y will be negative 1. So that will be your turning point coordinates. So the x value is 1. Then our y value will be minus 1 as the turning point coordinate. So that's the first thing that you want to know about this type of parabola. So that's the first thing that you must know about this type of parabola. So yeah, that's an examples. And then you guys in the comment sections, you can try other example of this type of parabola and do them as many as you can. And then you can comment and tell me the type of parabolas that you guys found. So in the next 2 minutes, I want to show you guys another type of parabola that you can get. The second type of parabola that you can get can be in this type of expression. Let's say we can have 1 y is equals to, or it can be fx is equals to that. So this one will have a there. You're going to have a there. And then you're going to open the bracket. Can either be x plus p. You can get x plus p, for example. You can get it as x plus p now. And then you're going to close the whole thing. And then you're going to put a square there. And then you can have plus q now. So this looks a bit different from the previous one. Just be careful of that. This looks completely different from the previous example. So again, the concept of a is still the same. If a is less than 0 or a negative, you get a Z parabola. If a is positive or above 0, you get a smiley parabola. But the only thing that, remember, we need to find the turning point coordinates as well. So to find the turning point coordinates of this type of parabola, mostly we use your P and Q. So the P and Q values are your turning point coordinates. Don't forget, guys, in this parabola, the P and Q values are your turning point coordinates. So meaning if tomorrow I were to give you, let's say I give you a parabola, an example of parabola. Let's say it's -2 outside. So a is -2. And then you open the bracket. And then let's say we get x plus, just call it x plus 3, for example. So if it's x plus 3 and then minus 4 outside, let's say we get minus 4 outside. And don't forget the squared. Whatever you do, don't forget the squared. This whole thing must be squared. Don't forget the squared there. So now, if they ask us for the turning point coordinates of this parabola, remember it's p. Here we are having x plus 3. So always remember, if the sign inside the bracket is plus, therefore your p value will be negative. And then q always remains as it is. So the q value that you are having will always remain as it is, which will be minus 4. So that will be your turning point coordinates. Q will remain as it is. But if on the bracket it's plus, let's say it's x plus 3, p must be -3. But if tomorrow, for example, let's say on the bracket tomorrow, for another example, let's say that they're giving us x minus 2. On the bracket there, it's x minus 2. So now, and then remember it must be squared outside. It must be squared outside. Let's say it's x minus 2 outside. And then let's just say plus 3 now. Just use a different example. So here, y is equals to that. So therefore here, our turning point will be different from the previous one. Remember, it's x minus here. If it's minus, therefore the p must come back as positive value, which will be 2. So the p value will be 2 here, and then the q value always come back as it is with its sign, meaning it will come back as 3. So therefore 2 and 3 will be our turning point coordinates. So that's how we find that turning point coordinates. So yeah, and then that will be all for this session. So on the next video, I'm gonna do the third type of parabola, which you're gonna get a lot these days. And also the third parabola is linked to calculus. So I'll show you guys how to do it, and then from there onwards I'll do some examples. from past papers.